we're going to use all of the information that we've had up to now to create a graph, a pretty good sketch of a graph of our polynomial. Okay. So we always need to find our zeros. So we find our zeros by doing our P over Q. We find one that works using our calculator. We synthetically divide to show that it's a factor. Sometimes you need to do it more than once, and then you either factor or use the quadratic formula to find all the rest of the zeros. Then you use the multiplicity of each zero to decide if it crosses or bounces, and put that information on the graph. Figure out the y-intercept by plugging in 0 for x. Right? Then you're going to use your leading coefficient test, so you're determining the degree and what the end behavior does. And then you're going to use all of that information to create a sketch of the graph. So it's very similar to what we did yesterday, just after we find the x-intercepts, you have to keep going on your information. So here we're going to find our P over Q. So remember, P is the constant and Q is the leading coefficient. So we have our P over Q, or our list of possible rational zeros, is plus or minus 1 and 2 over plus or minus 1, which just simplifies to plus or minus 1 and 2. I'm going to put this into my calculator. You can either use the Desmos graphing calculator or the calculator, the TI calculators, or a graphing calculator app. Any of those are fine. So if we go to our Desmos, I already put this graph in there because I can never remember what the equations are. Okay, so we have these three x-intercepts. I'm looking for one of them that is on our P over Q list. So 2, 0 is on our P over Q list. If you're going to be using your TI calculator is what I wanted to say, you can graph it. Okay, so here I would want to use the second calc, or second trace, number 2 for 0, and then I know it's I'm going to hit 0 because I know to the left, it's to the 0's to the left of the x-intercept, and then I know that 5 is to the right of the x-intercept, and then I'm going to hit enter, and then it will find our x-intercept. Oh, I did it. Let's try again. Oh, I guess that way doesn't work on this one. So we're at x-intercept of 5. So now my cursor's to the left, hit enter, my cursor's to the right, and our x-intercept is at 2. So either way, whichever one you do it, you get your x-intercept of 2. So now I'm going to synthetically divide by 2. So I go back and I look, I've got cube squared 1, none, so nothing is missing, no power is missing. So I've got 1, 1, negative 5, negative 2. So I bring down the 1, 2 times 1 is 2, 1 plus 2 is 3, 2 times 3 is 6, negative 5 plus 6 is 1, 2 times 1 is 2, negative 2 plus 2 is 0. Right. Remember, our pattern is multiply, add straight down, multiply, add straight down, multiply, add straight down. This 0 here means that this is indeed an x-intercept or a factor or root solution. It was a cubed power, so that means that this is now squared. So if I'm looking to find the rest of my x-intercepts, I can see, okay, can I factor this one, which I can't multiply to 1 and add to 3, so I can't factor, so now I have to use the quadratic formula. Remember, our quadratic formula is x equals, if you don't know this, you should memorize it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we plug that in, we get negative 3 plus or minus the square root of 3 squared minus 4 times 1 all over 2 times 1. So we get negative 3. This will give me 9 minus 4, which gives us plus or minus root 5 over 2. So then these are my x-intercepts. So we have x equals 2 from our synthetically dividing, and then we have negative 3 plus or minus root 5 over 2. Each one of these shows up once, so these have a multiplicity of 1. the roots do. And the 2 shows up once, so it has a multiplicity of 1. So both of these are odd and crossing. Now, I need to figure out where this is located on the graph. So we're going to put this into our calculator so we can know what number that is. So -3 plus root 5 over 2. So -3 plus square root of 5. Get out of the root, close my parenthesis, divided by 2. Yeah. And then you can do the same thing, -3 minus root 5, but just change the plus root to the minus root, and then divide by 2. So we get -0.38 and -0.26. So -0.38 and -2.6. I forgot. Yeah, 2.6. Okay. So now I can put this information on the graph. So we cross at 2. We cross at -2.6, so like there-ish, and -0.38, so about there-ish. I need my y-intercept, so I can plug in 0 into my original equation. So if I do f of 0, I get -2. Remember, all of these go to 0, so I just have this left over. So -2 is here. Remember, your y-intercept doesn't have if it bounces or crosses, it just is. And then we have this is an x cubed, so that means that it's going to be discoing. Since it's positive, it's going to look like this shape. So now I'm going to put all that information together to get my graph. Okay? So I'm going to come from the bottom left. I'm going to cross here, and cross there. Okay? Now, when we're sketching our graphs of our polynomials, we're not worried about how high up or down your min or max values are, these hills and valleys. We're just worried about your x-intercepts, your y-intercepts, what's happening at the far ends of the graph. Okay? And that gives you your graph. Notice it will match the picture of the one that we created on the Desmos, right? It looks very similar to this one. That's because this is what the actual graph is. Okay? If we take a look at our next one, we can do that same thing. Now notice this one is a 4th power, so we're going to have to probably synthetically divide twice. So here I'm going to find my p over q list. So we're going to do plus or minus 1 and 24, 2 and 12, 3 and 8, 4 and 6. That was perfect spacing. All over plus or minus 1, which just gives us, all of those are divided by 1. So plus or minus 1, 2, 3, 4, 6, 8, 12, 24. So this is my possible rational zeros. So I'm going to put this equation into my calculator to see where it crosses. So I'm just going to use the Desmos one. So this is what our graph looks like. So we have this right here, which is at 2. Now notice it bounces at 2, so I can synthetically divide by that number twice. So I'm going to synthetically divide by 2 to begin with. So I look cubed, or sorry, this is a 4th power. We skipped the cubed. And then we have squared 1, none. So I need to make sure that I put that 0. So 1, 0, -6, -8, 24. So I bring down the 1, so 2 times 1 is 2, 0 plus 2 is 2, 2 times 2 is 4, -6 plus 4 is -2, 2 times -2 is -4, -8 plus -4 is -12, 2 times -12 is -24, 24 plus -24 is 0. Okay. Again, we're doing multiply, add straight down, multiply, add straight down, multiply, add straight down, multiply, add straight down. This means that the 2 is an actual x-intercept. So we're synthetically dividing. We already know this because we looked on our calculator. But this is showing that we know that this is an x-intercept. Okay? But remember on our graph that it bounced here, which means that the multiplicity is at least 2. It could be 2, 4, 6, or 8. So I can synthetically divide by 2 here again. So remember, when it's a power higher than 3, you use the answer of your first synthetic division to divide by a second time. So I'm going to use 2 again. So I bring down the 1. So we do 2 times 1 is 2. 2 plus 2 is 4, 2 times 4 is 8, negative 2 plus 8 is 6, 2 times 6 is 12, negative 12 plus 12 is nothing, 2 times 0 is 0, 0 plus 0 is 0. Now remember, on your second set of synthetic dividing, you need 2 zeros. This was a fourth to begin with, so this one here is really your x cubed, which knocks this one down to an x squared. So our leftover is x squared plus 4x plus 6. I'm going to look and see, can I multiply to 6 and add to 4, which I cannot, so that means that I have to use the quadratic formula. So our quadratic formula, we have this is a, this is b, this is c. Remember, the a goes with the x squared, the b goes with the x, and the c is the constant. So I'm going to do x equals negative b, so negative 4 plus or minus the square root of b squared, so 4 squared, minus 4 times a, which is 1, times c, which is 6, all over 2 times a, which is 1. So 4 squared is 16, 4 times 1 is 4, times 6 is 24, it's still a minus, so we get 16 minus 24, so it's negative 4 plus or minus, and then if we do the 16 minus 24, that gives us negative 6. Or sorry, negative 8 over 2. So 8 we can break down to 2 and 4, and then this is 2 and 2. So we have a pair of 2's and then a loner 2. So we get negative 4 plus or minus, the pair of 2's comes out. Because it's a negative underneath, I have an I. We have a 2 that's left over, and then divided by 2. These have a common factor of 2, so I can divide by 2 on each one of these. So then we get negative 2 plus or minus I root 2, and then everything is over 1, which just keeps us at the negative 2 plus or minus I root 2. Okay. We also have our x-intercept from over here, right? So we need to add that to our x-intercepts. I should probably get rid of my box now. So 2, that came from here. Remember, when you use the quadratic formula, each one, so the plus 1 is a multiplicity of 1 and the negative 1 is a multiplicity of 1. So these are multiplicity of 1, so they're odd. We're not talking about crossing since they're imaginary numbers. If we look at this one showed up twice. So its multiplicity is 2, so it's even and bounces. So the 2 is the only thing that I'm going to have on the graph from our x-intercepts, because these are imaginary, which don't show up on our real number system graph. Okay. I go back and I look here. We can find our leading coefficient is 1 and our power is 4, so our end behavior is touchdowning and it's up, up. I also can find my y-intercept. If I plug in 0, that gives us 24. Okay. So I'm going to scale my y-axis. So we can go by, let's just go by 4. 4, 8, 12, 16, 20, 24. So this is my y-intercept. Okay. So then I'm going to create my picture. Now that I've got my y-intercept, I know my end behavior, and I have all of my x-intercepts that I've put here, and I'm going to create a picture. Oops, I missed. Now, there's nothing to say that I don't have this little part right here. We've looked at the graph over here, so we have an idea of what it looks like. I mean, we could scroll out. Also, see, look, over here, we've got this part here. Okay. Now, since we're just sketching a graph, this is fine for a sketch of the graph, as is just a U shape like a parabola. Okay. We're just concerned right now about our x and our y-intercepts and then what's happening with our end behavior. Okay. So that's how you can use all the information that we've been learning about to create a graph of our polynomial.